I've been transforming this 2009 Mustang, started off as a V6 into a 5-liter GT. And the way I'm doing that is taking basically everything from a donor 2014 Mustang GT, wiring harness, engine, transmission, rear end, everything basically, and swapping it into this '09 body. One of the more challenging things I've run across so far is getting the taillights to work in it. This car has incandescent bulbs and the 2014 has LEDs. So in this video I'm going to talk about how I made that work, and I'll explain that schematic a little bit later on. As you can see, I got the tail light working in the 2009. It's flashing in sequence just like it did in the 2014. But it wasn't as simple as just repinning a connector. I tried that, and since the 2014 is an LED taillight, it basically sees these incandescent bulbs and thinks it's a short and shuts down the body management computer. So what I had to do to get these taillights to work is build a series of relays. And that's what you're hearing clicking away, is those relays clicking. But I'll just show you on this tail light here. If I don't do something else, what I get is this. And that's just a rapid flashing of all the bulbs. And the reason it does that is because the body management computer just sees the relays and not the LEDs and thinks it's an open, or the LEDs are burnt out, and it goes into this default mode, and that rapid flashing tells you need to do something to fix your taillights. So anyway, what I did to get around that, just temporary, and I'll turn this back on again so you can see, is I put the 2014 taillight in the trunk here and just basically hooked it up in parallel with that light. And there's a control wire on there. I believe it's control wire. Normally it has 5 volts on it. And it senses when those lights are flashing and the voltage changes on it. I'll just shut this off again so it's not quite so annoying. Okay. So that 5-volt line, when there's nothing on here, it's sitting right about at 5 volts. Actually, it's 4.53 volts. And if I turn on just the running lights, it goes down to 4.45 volts. If I have just the reverse light on, it still sits pretty close to that 4.53. However, when I put the brakes on, it goes down to 2 volts, and the brake lights up the same 3 bulbs that are active when the turn signal is going. I'm not able to read what the voltage drops to when the turn signals are going because it's flashing off and on too fast. My voltmeter just doesn't respond to that. So the next thing I did is I checked the resistance, and that 5-volt wire, or 4.53 volt wire, if there's nothing turned on, it's got a resistance of 10.5 megohms. And I believe that's the resistance just going back through the body management computer. When I have the brakes on, it drops to 1.5 megs. If I just have the running lights on, I never did check the reverse, but the running lights, it stays at that 10.5. So I believe I have to put some resistors in there to get that resistance down to 1.5 megohms when all 3 lights are on. And then maybe I can build some circuitry where I don't have to have these tail lights sitting in the trunk just to get my my lights working properly here. So anyway, I'll do some more research on that, see if I can find a circuit diagram or a schematic of these taillights. That would make it a lot easier if I had that, and I could tell exactly what's going on inside there. But I'm going to try to duplicate was going inside just with another couple of relays and some resistors, and hopefully I can build something so these tail lights will work. The other thing I had to do to get the brake lights to work properly is switch out this bulb up here. It was an incandescent bulb. Don't know if I've still got that in here. No, I don't, but it's just a little incandescent that was sitting right there. And what I did was I actually took the LED strip out of the high mount tail light from the, or brake light from the 14. And then took a Dremel tool and just ground off these little plastic pieces here, and I was able to pry off that whole strip in there. You can see it up in there. And then fasten it up in here and use the original connector that was on the harness from the 2014. And it works, it lights it up, it's very visible and stuff like that. And then to hold it in, I couldn't see how to do that really, so I just used some heater hose. Shoved it in to here. I took out the original light bulb first, and I had these two little brackets coming down, shoved heater hose in on either side, and a couple of zip ties, and it seems to be pretty solid. So that's how I got the brake light to work. So now I'm going to do a little bit more experimenting and see if I can build a circuit to make this a little bit more permanent than having that tail light sitting in the trunk. Well, I was able to build some more circuitry and get the sequential taillights working. What I did is I added another 3 relays and a potentiometer. And I'll just put the signals on to show how it works. So I'm getting the sequential flashing now without having the other tail light in parallel, which is good. And with this potentiometer here, you can see if I just increase the resistance a little bit, it goes right back to flashing like it did. So just turn this back right there. Okay, so I'll explain the circuitry and how I made that happen. I'll just shut this off. Okay. And I just drew up a really crude schematic of how this all works. And this is the harness that comes from the 2014. And there's, what is there, 6 wires? Yeah, 6 wires. You got 1 wire for the reverse light, running lights, and then 1 for each of the 3 tail lights there. And there's this 5-volt control wire as well. What I tried at first is just hooking up these wires directly to the taillight, and that didn't work because these incandescent bulbs drew too much current and it shut the computer down, basically tripped it, and I had to reset the computer by disconnecting the battery to make it work again. So to get around that problem, I added relays, 5 relays, and each relay has the 12 volts here, so this now just provides a signal to close the switch and provide light to the light bulb, so it's getting its lighting directly from 12 volts. That worked, but I still had the fast flashing. The computer was thinking that 1 light bulb was burnt out, so the way I got around that is I added another 3 relays down here, and I just tapped off these lines, the lines that go to the light bulbs. So when a signal is received, let's say on this line, it goes down to this relay at the bottom here, closes that relay, and this control wire sees a resistance here through the potentiometer. And at first I tried 3 potentiometers in there, and that worked as well. But the problem with it is it lowered the voltage way too much on this 5-volt line. When the brakes are on, this line with the taillight in there, the old taillight, the 2014, wanted to see it drop down to 2 volts. It dropped down to 0.7 volts with the 3 relays, or 3 potentiometers in there. With only 1 potentiometer, with all of these connected together and running through 1 potentiometer, the voltage now drops down to 1.4, which is still lower than what I'd like to see. And I do have a potential solution for that. as well. We'll see if 1.4 is still okay. It might still be within the tolerances, and may not get an error code or a code on the computer saying that I've got a problem with the brake circuit. If it does work that way, it's great. If not, what I'm going to try is this circuit over here. And this is basically the same as that, but instead of having 3 separate relays, I'm going to only have 1 relay and diodes. And what these diodes do is prevents these 3 lines from interacting with each other. If I didn't have the diodes in there, and if I just hooked all these wires together through 1 relay, anytime one of these lights were lit up, all 3 would light up, and the diodes will prevent that from happening. And I'm hoping by only using 1 relay, it's a little bit less resistance there, and I won't have quite as much voltage drop, and I'll be closer to that 2 volts. So anyway, that's what I'm going to try on the other light. I'm in a small town, and I just can't run to town and get diodes. No one sells diodes in town, so I've ordered diodes. It'll take about a week to get here. So I think what I'm going to do is post this video now, and then I'll provide a comment after I get the diodes in place to let you know if that works better. Or for sure in a future video about the car, I will let you know if this all worked out, and if I don't get any error codes as far as a bad resistance on the braking circuit. Or if you get questions, definitely leave me a comment and I'll do my best to answer them. The other thing too, after doing all this and doing all this experimenting, and without having the benefit of having a schematic for the car and a taillight here, I thought about ordering the wiring diagram book for the car. That was $100, but I wasn't even sure if it would have had the circuitry inside the taillight, which I needed, so I didn't bother doing that. And so I just kind of guessed at what type of circuitry was in there, and as a result, I went through a bunch of experiments to get to this point. Looking back at it now, I think I could simplify this a whole lot just by changing these light bulbs out and putting LED light bulbs in place of the incandescents there. And that would get rid of all 5 of these relays, potentially. That all depends if the aftermarket LED taillights don't draw enough to trip the computer. That could be the case. It might draw too much, and especially I would still have to add some circuitry down here, and that might be just enough to throw the draw outside the limits, and that could cause a problem. But assuming it wouldn't, LED taillights over here get rid of all these relays, and then if I use diodes, I could maybe get the circuit down just to 3 diodes, a relay, and a potentiometer, or a fixed resistor once I know what that is. The value I found with this potentiometer was right around 700 ohms, which was surprising to me. I thought I would need a higher resistance in there to make this all work, but it seems like 700 ohms is where it likes to be. So anyway, if you're building something like this, you might be able to just buy a resistor, a 700 ohm resistor, and put it in there, but I would probably recommend using a potentiometer, and you want to get as close as you can to the limit there so that you can get the proper voltage drop on that circuit when the brakes are applied. So anyway, that's it. I'm happy the taillights are working. If you have questions, please let me know. Thanks so much for watching, and I'll provide another update soon.